In this video, I will walk you through the projectile problem that I assigned for AP Physics. So we're told a cannonball is fired at an angle of 30 degrees above a flat surface with an initial speed of 40 meters per second. So I'll make a sketch like this. This represents its initial velocity, and it is going at 40 meters per second. And that has a horizontal component and a vertical component. And the angle here is 30 degrees above the horizontal. And so what's the original velocity in the x direction and the original velocity in the y direction? Well, we can determine those from the angle and the initial velocity. So v naught x is going to be whatever the initial velocity was times cosine of 30 degrees, because cosine of 30 is adjacent over hypotenuse. So the hypotenuse times the adjacent over the hypotenuse gives you the adjacent. And, well, what's cosine of 30 degrees? Well, remember, if you have a 30, 60, 90 triangle, 30, 60, 90 triangle, the ratio of the sides is 1 to 2 to root 3. And so this is going to be 40 meters per second times, well, what's cosine of 30? It's adjacent over hypotenuse, so it's root 3 over 2. So the initial velocity in the x direction is 20 root 3 meters per second. And similarly, the initial velocity in the y direction is its initial velocity times sine of 30 degrees. And that is going to be equal to 40 meters per second times sine of 30 would be opposite of hypotenuse, which would be 1/2. So the initial velocity in the y direction is going to be 20 meters per second. These are going to be relevant for other parts of the problem, so I'll go ahead and put a circle around them. Okay, so first of all, we're asked what are the horizontal and vertical components of the velocity? Well, we just got that. That's the initial velocity. What's the maximum height that's achieved by this cannonball? Well, we don't need to worry about the horizontal component when figuring out the maximum height. All we need to do is worry about the vertical component of the velocity. So we need to first of all find out how much time it takes to get to the peak of its flight. Just to put this in perspective, let's think about this graphically. What's its velocity in the y direction as a function of time? Well, it starts out with a y component of the velocity of 20 meters per second, and it's going to lose 10 meters per second every second that it's in the air. So it's going to take, 2 seconds for it to lose all of its vertical velocity. That's assuming that the acceleration is downward at 10 meters per second. So it has 10 meters per second. Okay, so that's the downward acceleration. So it takes 2 seconds to get to its peak. How high does it get during that time? Well, that would just be the area under this plot right here. And so the area of that would be the height that it gets to is 1/2 of the base, which would be 2 seconds, times the height of that would be 20 meters per second. And so it's going to get to a height of 20 meters. That's the height. What's the range of the cannonball? The range would be the horizontal distance it travels during the 2 seconds that it takes to go up and the 2 seconds it takes to go down. So it's in the air for a total of 4 seconds, and it's traveling horizontally at 20 root 3 meters per second. And so we'll have 80 root 3 meters would be the range. Okay, so I'll go ahead and put circles around these because I guess these are answers to a couple of the problems or questions I asked. And then what's the velocity of the cannonball when it strikes the ground? Well, it's going to be the same velocity as it had when it was fired. So the final velocity is going to be 40 meters per second.